Hi, Integrated Science. This is Miss Satterley. I'm going to go over just a little bit about the periodic table today. If you've been in class, I've gone over some stuff. If you're a remote learner, this is for you to get a few things that I had gone over with them in person. So, the periodic table is one of the most important tools that chemists use, and it includes all of the known elements. Now, currently, there are 118. They have all been officially named. It used to be if an element was not officially named, it would have a three-letter chemical symbol starting with U, but now everything does have a name itself. I'm going to go over the families today in this video as well. I did post an assignment this morning and a picture to go with it that you allowed you to do that, but I'm going to verbally explain it to you as well. So on this actually has a couple things I want to point out. One, elements are put into groups, and groups are going to be the columns on the periodic table. There are 18 different groups. Periods are the horizontal rows on the periodic table. Now, the periodic table itself, if you look at this right here, you have your chemical symbol, you have your atomic number. Atomic number, as a reminder, is the number of protons. And actually, on this one, it actually shows you the number of electrons in each cell. That's just a feature that I wanted to point out to you. And then the atomic mass is the average of all known isotopes, and it actually includes the atomic name as well. This particular one is color-coded based on the groups that they're in. So our first one here, those are alkali metals, and they're in the gold color. Then alkaline earth metals. Lanthanoids and actinoids, which are called the lanthanide series and actinide series, these are located below the periodic table just kind of to make them fit better. There's 15 in each one, and most of them are radioactive. Everything after 92 has been man-made. 92, our uranium is thought to be the highest or heaviest naturally occurring element, and it's the result of supernovas that have happened when stars die. The pink, those are transition metals. Those are in the middle. That includes familiar metals such as silver and gold, copper, zinc, nickel, iron. All of those are transition metals. The light blue right here, these are post-transition metals. They have different properties. I've talked about gallium several times. Gallium is the metal that has a melting point that is so low that it will melt into your hand. So all of these are post-transition metals. But the dark green, those are what we call metalloids. And actually, if you include a ladder here, it actually shows you which ones are metalloids. Metalloids are elements that have characteristics between those of metals and nonmetals. They can appear many different kind of properties that I'm going to go over. I actually going to show you some different elements today just so you can get an idea what some of them look like. The light green, those are other nonmetals, which means some of them are gas and some of them are solid. Hydrogen is a gas. Carbon is a solid nonmetal. Nitrogen is a gas. Oxygen is a gas. Phosphorus, sulfur, and selenium are all solids, but they're all considered nonmetals. The teal, those are halogens. Halogens are all extremely toxic. Fluorine, chlorine, bromine, iodine, acetine, and tennessine. And then the last group is the noble gases. And noble gases are all inert, which means they don't react. And that's the periodic table. When you have periodic trends, when you go this way, you tend to have heavier elements on the periodic table. Well, except for the lighter ones up here, but as you're trending this way, and that's because they have more atoms in them. As you go down a group, The elements at the bottom are a lot more reactive than the elements towards the top, and that's because they're more unstable. So francium is the most reactive alkali metal, while lithium is going to be the least reactive. All of these alkali metals and alkaline earth metals, actually, when you do the flame test, they will have colors that show up because of their electrons that are jumping between levels, and that's why those salt compounds are used in fireworks to have different colors. Also, both of these will actually react pretty violently with water, creating heat and light. Now, the ones at the bottom react more violently than the ones at the top. So this is a general overview of the periodic table itself. So the periodic table was actually developed by an individual called Dmitry Mendeleev. And he actually wrote all of the different elements onto cards and looked at their properties and then organized them that way. And that's how we have our setup of the way it is now. So here's also a periodic table. And on this one, I'm going to go over the different families. So some of these we already looked at. The family names are based on the type of metals that they are. Some of these I have not mentioned yet. So the first one are alkali metals, which I have at the top. And then group 2 is alkaline earth metals. Transition metals are the ones in the middle. The boron, carbon, nitrogen, and oxygen family, sometimes they're considered the B, C, and O group, but they do all have their own names. Boron family are earth metals. The carbon family are tetrals. The nitrogen family are called pnictogens. Halogens are the oxygen family. Fluorine are known as halogens. And then your last group are noble gases. And then we have 2 more groups at the bottom, the lanthanides and actinides, or lanthanide series and actinide series. Again, those are those 15 elements that are pretty reactive. So if you can see, I just want to point out, here are some of those unofficially named elements. So this was actually printed in 2013. So 7 years ago, these elements were not officially named yet. But this one is newer. So we actually see these new ones: nihonium, ferrovium, muscovium, livermorium, tennessine, and oganesson. So all of these are those officially named elements. Last thing I want to do is I just want to show you a couple different elements, what they look like. I'm going to start off with 2 of those other nonmetals, sulfur and carbon. I'm going to open these up here. Carbon. Carbon comes in many different forms. It is a very useful compound. It is found in all living things. You cannot be alive without carbon in you. You have tons of carbon in you as well. This particular carbon, this is graphite. So if I was going to take this, I actually could draw on a piece of paper with this, which, you know what, I can do just for fun. So if you see here, it doesn't show up very well, but you can see, so that's graphite. Carbon also is found in diamonds. It's just looks different because it has a different chemical composition of the way they are bonding together. The bonds form, but they are the same element. This one is sulfur. Sulfur is another non-metal that's a solid. Sulfur actually smells like rotten eggs. It's yellow. It's very dusty. It actually is getting on my hands right now, but this is sulfur, which is a type of non-metal element. I do happen to have a metalloid. I have some silicon. So right here, get a piece of this out. So you can see this is super shiny. It's glistening almost. We call this luster, which is the way light reflects off a material. This has a very high metallic luster. So this kind of looks like a metal, but it's actually a metalloid. So it has characteristics. It has a lower melting point, not as low as gallium does or anything like that. So it's not really a true metal. It's a metalloid. Now the next thing I have is, I'm not going to open this one. This is actually magnesium. So magnesium is an alkaline earth metal. You can see some of it's sticking to the container. It has a lot of static electricity in it. If I open this, some of it would probably go flying out just from the static electricity from the electrons. Again, this would be very reactive with water. It would form a little bit of heat and light, not as much as if I had calcium or strontium in water. But this is an alkaline earth metal. Next, I actually want to show you two post-transition metals. So I have here, this first one, this is aluminum. I always think it kind of looks puffy in appearance. It kind of looks like a metal marshmallow almost. Aluminum is very light. We use it for a lot of things. It's in aluminum cans. It's an aluminum foil. It's very useful. It has a very high melting point, which makes it good for aluminum foil that you can use for cooking and stuff like that. So this is aluminum. This one here is tin. Tin is also considered to be a post-transition metal. Tin's a little heavier though. It's like one little piece of this is probably almost the same mass as one of those bigger, maybe a couple pieces, but this is tin. You can see they kind of have some similar properties. They're both kind of a more dull appearance. So these are both post-transition metals. And last, I have 3 transition metals here. Some of these probably look familiar. So here we are. This is copper. Copper is a very common metal. It's used in a lot of electrical work. Really conducts electricity well. Copper wiring is used for a lot of things. You can see some of these are kind of dull. That's because they've been oxidized, which means they've come in contact with water and they've rusted a little bit. But, well, it's not really rust because rust is iron oxide, but they have oxidized. I'm not going to touch that one. This is very, very heavy. Copper is pretty heavy too, but this is lead. These are lead pellets. You can see it has a kind of a dark gray color. That's lead. And then this one is zinc. Zinc is another type of transition metal. Zinc is usually pretty shiny. So this is a more shiny piece, but some of this has been oxidized as well, so it's a little more dull in appearance. So zinc. Zinc is the lightest of the 3. So again, we have lead, copper, and zinc. So with this video, I have posted a Google Doc that has characteristics of metals, characteristics of nonmetals, and also characteristics of metalloids that I want you to use. There will be a homework assignment that we'll post by the end of today that will just ask you some general questions about the periodic table, metals and metalloids, and then about the different families. I do have a document that has information on that we worked on together in class. Just some things. So noble gases are inert. They don't react. Halogens are super reactive and they're very toxic, most of them. Again, these are both reactive metals. Both of them will actually react with water violently. So that's one of the things. Down here, your lanthanides and actinides are both super reactive and radioactive as well. And that's just kind of a little overview of some of those characteristics, but that'll be on part of the homework as well. Okay, so this is just overview of the periodic table. If you have any questions, please let me know. Have a wonderful day. Bye.